Mixtures: chicken soup, clouds, cookie dough, mud, cereal, gasoline, blood, coffee, concrete, sand, your favorite soft drink, even the air you breathe.
Mixtures are a combination of two or more substances that do not undergo a chemical reaction. Mixtures can be any combination of solids, liquids, and gases.
Italian salad dressing, for example, is a mixture of all three.
You can see the herbs, the solids, and the air bubbles, the gas, mixed in with the oil and vinegar, the liquids.
The components of mixtures can be separated through evaporation, through gravity, or through other mechanical means. Mechanical methods of separation can be as simple as picking olives off of a salad, using a filter to clean the air,
or using a magnet to separate iron filings from sand. Some mixtures can be separated utilizing specialized equipment. For example, a washing machine removes water from its load by spinning. Similarly, a centrifuge forces denser substances to the bottom by spinning a sample very quickly.
There are two kinds of mixtures, homogeneous and heterogeneous. These names are based on the Greek root words, homo meaning same, and heteros meaning different. The components of homogeneous mixtures are uniformly distributed, whereas the components of heterogeneous mixtures are not.
Mixtures like oil and water, cereal and milk, and salads are called heterogeneous mixtures. The components in heterogeneous mixtures are unevenly distributed. Components may be as large as lettuce leaves in a salad, or as small as water molecules in an oil and water mixture.
One example of a heterogeneous mixture is when we put food coloring in mineral oil. The food coloring remains in the form of droplets that settle to the bottom of the container. The two components are not distributed evenly and make a heterogeneous mixture.
There are many different kinds of heterogeneous mixtures, including suspensions, which are solid particles in gas or in a liquid that settle out due to gravity, like sand and water. Another kind of heterogeneous mixture is an emulsion, which is a combination of two different liquids that separate out from one another, like oil and water.
Homogeneous mixtures, on the other hand, have an even distribution of substances throughout. Everyday examples include coffee, salt water, and homogenized milk.
The substances in a homogeneous mixture tend to have smaller particle sizes than in a heterogeneous mixture. In some cases, the particle size is too small to be distinguished from the other substances. Notice how the food dye distributes evenly throughout the water, forming a homogeneous mixture.
The food coloring cannot be distinguished from the water in the same way that dissolved sugar cannot be distinguished from coffee. Although they cannot be seen, both substances are still in the mixture.
There are many different kinds of homogeneous mixtures, including solutions and colloids. A solution is a homogeneous mixture whose components form a single phase. In the case of sugar and water, you can have a solid dissolved in liquid, but the outcome is a single-phase liquid. Colloids are mixtures where fine particles are dispersed throughout another substance and tend to have a cloudy appearance, like milk.
To recap, a mixture contains two or more substances that are held together by physical forces and do not create a new substance. Mixtures can consist of any combination of solids, liquids, and gases.
Mixtures can be separated by many approaches, such as evaporation, gravity, or mechanical means.
Mixtures can be heterogeneous or homogeneous. The components in heterogeneous mixtures are unevenly distributed, whereas homogeneous mixtures are evenly distributed. So now you know.
So good morning everyone. Today before I start the lesson I showed this small video clip about mixtures, and it's nothing new. It's all about that we experience in our day-to-day life, things that you eat, air that you breathe, water that you drink. They all not pure, they are mixtures. So grade 10 chemistry, third lesson also. This is a summary like this. Actually, I will show that first, then it will be useful for you to understand this. most of the things that we come across in our daily life, not pure, they are mixtures. Let me show you that also, the grade 10 third lesson. Here you can see grade 10. This is grade 10 third lesson. So they are also, you learn about pure substances. You can see matter can be divided as pure and mixtures. Here we are going to discuss about this side, only about mixtures in detail. Grade 11 unit 3. So this one you learn in grade 10. This one you learn in grade 10. Right. So pure substance means you can, there's a chemical formula. Pure substance has a chemical formula, but mixture has no chemical formula. That is one of the easiest method to distinguish pure substances from mixtures. Pure substance has a chemical formula. Has a chemical formula. Mixtures, no chemical formula. No definite chemical formula. This one, no chemical formula. You cannot give a definite chemical formula. That means composition is not definite. In a mixture, we can't write a chemical formula for it. Example, salt solution, you can't give a chemical formula. Sugar solution, you can't give a chemical formula. Lime and water, or sand, rice and sand. Rice should be RICE, rice here. So they all no definite formula, or cannot be represented by a chemical formula. Cannot be represented by a chemical formula. By chemical formula. So example, if you take now water, sometimes you might think we are drinking pure water. Actually, we are not drinking pure water. We are drinking mineral water. Mineral water also a mixture. Mineral water that you drink, water bottles, tap water, or tap water, sea water, or mineral water, well water, they all mixtures. If you allow 100% pure water, you can't drink. If you drink 100% pure water, you will die. Ultra pure water or research grade water, only H2O. Actually, you cannot find 100% pure water in the nature. I'll give one example. Imagine even if you take 100% pure water into a glass or bottle, immediately after opening the lid, what happened? Germs, dust particle, and atmospheric gases get dissolved in this glass of water or the bottle of water. So they are this atmospheric CO2, dust particles, they all get dissolved in water. Therefore, it can't be pure. It will become a mixture. That's why it's very difficult to have 100% pure water around us. Then you have to keep that water in a vacuum, like without any gases that can dissolve in water, free of germs, dust particles. Therefore, if you take soda water, it's mixtures. The food that you eat, mixture. Therefore, mixture, to become a mixture, there are two requirements. To become a mixture, combination of two or more components. Minimum two components required to form a mixture. Right? Minimum two components required to produce a mixture. Mixtures are classified as homogeneous and heterogeneous. This is grade 10 textbook chapter 3, nothing new. Grade 10 textbook third lesson, you had this summary. And matter, actually chemistry is the field of the study of matter and its properties. and how they interact matter. Chemical reaction, how matter interact in chemical reaction. Matter can be solid, liquid or gas. And matter can be divided as pure and mixtures. Mixtures means non-pure. Chemically, sometimes you might tell us we are drinking pure water. Yes, that is not chemically pure. Therefore, it's very important to understand the meaning of a mixture. To become a mixture, so if it is only one component, it's pure. So combination of two or more components. Combination of two or more components mixture. Combination of two or more substances. Combination of two or more substances form the mixture. Right. Then we'll move to the theory tube now. I'll trace this. If you want, you can take a screenshot. To become a mixture, there must be at least two substances. And the other most important thing, these mixtures means they don't chemically combine. They are physically mixed. Therefore, you can separate them by physical method. If they are just mixed physically without any chemical bonds, you can separate them back to the original components. Example, you can get salt out of water by evaporating water. You can get sugar crystals by evaporating water. It's a physical method, evaporation, filtration. There are many physically you can separate. I will show the PowerPoint slide also. Look at here. We use different technique to separate them. If you go to the paddy field, use this physically separate sand and rice. So this is winnowing pen. I don't know whether you have seen this. Is in single we call it cooler. And you can see now. You can see this based on the size of the particle. You can separate this. If you go to the kitchen, milk strainer, kirigotta, you can see it's a separation. Physically separate this, but not into 100% pure. So if there are magnetic properties, so maybe iron particles, you can separate from sulfur. Sulfur is not magnetic material. Sulfur is a non-metal. Gem mining again, separation of the gem from the sand and mud. Gem mining. Filtration, all this physical method. Distillation, we are going to discuss all this one by one, don't worry. Fractional distillation, steam distillation, chromatography, all this separation technique, right? So mixtures can be separated by physical means. In other words, can be separated by physical methods. Now you have about this basic understanding about mixtures. Now theory tube, chapter 3, mixtures. So this is the first lesson under grade 11 chemistry. First two lessons actually biology. Unit 1 living tissues. Unit 2 photosynthesis. Now this is the third lesson chemistry. The other two lessons physics actually. Grade 11 first term you are supposed to complete until unit 5. Grade 11 first term test based on grade 10 everything, and grade 11 up to unit 5. Unit 1, 2, 3, 4, 5. So this is your first term work. Grade 11 first term. But anyway, it's term wise breakdown now. It's like, it's like the school term also now change. So this is your first term. These two biology. This is chemistry. And unit 4 and 5 physics. Remember, after unit 5, then you get unit 6 biology. That is second term. That is the longest lesson, system lesson. After unit 6, all the remaining lessons until the last lesson, only chemistry and physics. Only chemistry and physics. Therefore, grade 11 syllabus, Actually, biology lessons very few. Most of them chemistry and physics, grade 11. And you are getting from this grade 11 lessons essay type questions in the oral paper. Essay type questions. Okay, now you can see the first one, the mixtures. You can complete the blank. A combination of two or more components, look at the screen, which are not chemically combined. Which are not chemically combined. Complete the blank. Which are not chemically combined. And can be separated by physical methods. Physical methods means if you only write few examples within bracket, evaporation, filtration, crystallization, etc. Right. Chemically, not chemically combined, not chemically bonded. They have given this in your textbook also. Right. Now, those who join late, you can copy down before I erase the first one. Next one, I have given a table. You have to classify them as pure mixtures. How to decide whether a given substance is in a pure or a mixture? If you can give a chemical symbol or chemical formula, then it is pure. If you can give a chemical formula or chemical symbol for a given substance, it's pure. Right? So you can write, say, example, gold. Gold is AU. So it's a, if you can see whether before you write whether it's pure or mixture, see whether you can give a chemical formula. So gold, we can give a chemical symbol. Gold, the symbol is AU. So therefore it's pure. Brass. Brass, you can't give a definite chemical formula. Brass combination of what? It's copper and zinc, higher percentage of copper and lower percentage of zinc. It's a combination of two metals. Therefore, brass will be a mixture. It's an alloy. So all the alloys are solid homogeneous mixtures. If you can write down this in a short notebook, all the alloys, brass, bronze, duralumin, all the alloys are solid. That means combination of two metals, solid homogeneous mixtures. All the alloys, I will highlight the word alloys. Alloys are solid homogeneous mixtures, including brass, bronze, duralumin. Now air that we breathe also a combination of many gases. So can you give a chemical formula? No. Therefore it's a mixture. Air that we breathe consists of many gases. It's not pure. Air that we breathe consists nitrogen gas, hydrogen gas, carbon dioxide, because 0.03% by volume in the atmosphere carbon dioxide. Oxygen 21%. Air that we breathe contain highest proportion nitrogen gas N2. Air that we breathe can contain coronavirus. Air that we breathe can contain bacteria. Air that we breathe can contain fungus. Air that we breathe can contain dust particles. So we don't breathe clean air. We don't breathe pure air. Water that you drink also not pure. Tap water contain minerals dissolved in it. Therefore, this is what you have to understand. Therefore, many things found around us, most of the things actually they are not pure, they are mixtures. Right? Shall I erase the screen? Anyone still copying down this? Done, right? Those who are still copying down this, please raise the hand because I'll erase this. This one you can write, these all the alloys are solid homogeneous mixtures. You write separately somewhere this additional point I gave. They will never ask, like, O-level paper now, new syllabus papers. They don't ask what are known as mixtures, what are homogeneous mixtures, what are pure substance. You don't get such baby questions now under new syllabus. But you should know what it is. You should know the properties of the mixture. And you should know the properties of pure substance. But they don't ask, don't memorize word by word any of these definitions except Newton's second law, third law, Ohm's law. You have to remember. But these things, some teachers, they give questions. They cover the lesson also through the questions. What are mixtures? What are homogeneous mixtures? And the students memorize them. And they think the same thing they'll ask in the exam. No. Oral science paper, they don't ask questions like that now. Recall in your just previous memory. They don't check the memory power much because there are many devices to store the data. You don't need to share much capacity of your brain now for storing data. There are many advanced storage devices available. Right. I'll erase now. You had enough time to copy down this. Next one. Glucose. So how to decide this easily? If you can give a chemical formula or chemical symbol, it's pure gold. So it's Au. So you can give a chemical symbol, therefore I wrote it's pure. Brass, you can't give a chemical formula, it's a mixture. Combination of two or more metals. Combination of copper, brass, zinc, Isod and zinc. Air, it's a mixture. Can you give a chemical formula for mixture? Can't. Air that we breathe, mixture of many gases. Glucose, that one we can give a chemical formula, C6H12O6, glucose. So therefore it's you can write that as pure. But this also I have to tell. If this is actually 100% pure gold. If someone tell 22 karat gold, 18 karat gold, is that pure? 18 karat gold, 22 karat gold, that is not pure. What is the difference between the pure gold and 22 karat gold? 22 karat gold contain gold plus copper. It's mixed with a small percentage of copper because you can't make jewelries with 100% pure gold. The reason, it's not strong enough. 100% pure gold we don't use for making jewelries. The reason it's not strong enough. Therefore, actually it's an alloy. 22 karat gold means it is an alloy. So then what H2O? Water we can give a chemical formula, H2O. Therefore, it's pure substance. It's a pure substance. It's pure. Complete the table. So I have posted this PDF to your WhatsApp group about 1 week back. You had enough time if you want to take a copy. Now the unit 1, the living tissues we finished. Just I have to highlight just the three main functions of the neurons, and I will show the video clip for that also. I gave the explanation already. I have given you, right? Photosynthesis lesson we have completed on last Sunday morning paper class. I discussed the questions also on the photosynthesis lesson, and the remaining questions I'll be discussing tomorrow morning paper class. So we are doing in the paper class Sunday morning unit wise revision also, in addition to the past papers, model papers, support seminar papers. Right. Next one. So tomorrow the structured essay type questions we will start. MCQs only we did, I think. I'll erase the screen. Please start joining on time. Again, there are students in the waiting room and many students joining late. Now remember, with curfew and with current prices in the future, I don't think you will find fuel to travel even to a physical class. Therefore, this time now you can see the oral exam is 23rd. This time oral batch the exam, and your exam scheduled to be held in December. And sometimes they might extend this maybe until January or February, but you have to get ready for December. Now it's May, so you have nearly 7 more months, 9 subjects. Some of the schools, they have not even completed the first term year, okay, or even they have just started the first lesson. But anyway, they will make the paper from the whole syllabus at the end. Next one, so I'll erase the screen. Then mixtures can be classified as homogeneous and heterogeneous. Look at the screen. Now homogeneous means homo means evenly distributed, uniform appearance. Mixtures in which the components cannot be observed separately. You cannot observe the components separately. Complete the blank, cannot be observed separately. And as well as properties same throughout, or components are evenly distributed. In other words, components of the mixture evenly distributed. Components are evenly distributed. Components are evenly distributed. Evenly distributed. If it is unevenly distributed, we call it heterogeneous. Components are evenly distributed, that is why we call it homogeneous. I'll give one example. Now you breathe air. It is homogeneous. Air that you breathe, homogeneous. Can you see the oxygen molecule? Can you distinguish from hydrogen molecule or carbon dioxide molecule or nitrogen? No. When you drink glass of water, can you see water molecule through your naked eye? Can't. So therefore, if you, I'll give one example. Cannot be observed. Components not visible to our naked eye, and the composition as well as properties same composition throughout. Composition same throughout. Physical properties also same throughout. Properties means what is the meaning of properties? Properties means what? Density, color, appearance. Properties means density, color, appearance. So that's what it means. Properties, physical properties, basically physical properties. I'll give one example. If you are going for a urine report, if doctor asks you to get a urine report, you get this to a sterilized plastic bottle, the screw type. This plastic bottle, screw type plastic bottle, and you take urine. It is transparent bottle. Mostly they use transparent plastic, not a colored one. So in the urine report, they mention whether the appearance, whether it's clear or not, whether it's pale yellow or whether it's cloudy. Appearance of the urine. It tells something about your urine is whether there are crystals or whether you have kidney stones or the bladder stones, or if you have protein in your urine, you get froth or penna form is coming. Therefore, this physical property is also sometimes important. Example now, if you want, I think I had urine report, but I'll show that later. Whether it's yeah, I had some medical reports. Yeah, it's here. Urine, yeah, I'll show that later. Okay. Properties same throughout. Appearance same throughout. Okay, if you want, you can write down those the list of the things, characteristics of homogeneous mixtures. You can write if you want in point form, because I don't think in the exam they will ask on the new syllabus paper questions to explain about to define about homogeneous mixtures. I don't think they'll ask questions. You better write separate in your writing book, right? Properties of homogeneous mixtures or the characteristics of homogeneous mixtures. Write everyone additional point in your writing book. Properties of homogeneous mixtures. Properties of homogeneous mixtures, write separately in the writing book. One property you can write. Physical properties, composition same throughout. Chemical composition, right? First one, composition same throughout. Composition same throughout. Or you can write evenly distributed. Evenly distributed. Or you can write uniform composition. Any of these words you can write. Uniform composition. Number 2. Physical properties same throughout. That means from place to place the physical properties won't change. Now if you take a rock, it's heterogeneous. In the rock some places hard. In a rock some places less hard than that. Some places dark in color. Color changes throughout the rock. Hardness, appearance different from place to place in the rock. Therefore, rock is not a homogeneous one. Rock also a combination of many minerals. But rock is, if you want to write that also, rock is heterogeneous. A rock. So what is the second property of homogeneous mixtures? Physical properties same throughout. Physical properties same throughout. In addition to that, components of the mixture not visible. Components of mixture are not visible. Are not visible to our naked eye. are not visible to the naked eye. Now last Saturday I started the grade 10 paper class also. Now I am starting now. Last week I started from unit 1 itself the revision. If any one of you have missed the grade 10, because some students, there are students those who join directly to the grade 11 now from grade 10 third term. If you have missed anything grade 10 first term and second term grade 10 work, no need to come to the grade 10 theory class. You can join with the, I strongly recommend grade 10 paper class. We are doing unit wise revision. Grade 10 Saturday 7 to 9. Saturday 7 to 9, that means Saturday evening. Saturday evening 7 to 9 p.m. grade 10 new paper class you can join to revise the grade 10 work through questions. No point of again copy down notes because you have the textbook note, but you need to practice what are questions you are getting from the grade 10, because you all our science paper you get 45 to 50% from the grade 10 work. That's why. Right, I'll erase the screen. Anyone still copying down? Is that done? These things you have to copy down separately, right? This one I gave separately. So in your writing book, everyone should maintain a separate CR book. Then we'll write some examples for this. What are the examples for homogeneous mixtures? One example you will write atmospheric air. In national you can write drinking water. Alloys you can write say brass. That's homogeneous. You can write glucose solution. Glucose dissolves well in water. Glucose solution. Or sugar solution. Copper sulfate solution. Copper sulfate is blue. Copper sulfate dissolves well in water. I'll go a small short method over this. Many ionic compounds completely soluble in water. Therefore it's homogeneous. Homogeneous solution. Any monosaccharide or any disaccharide with water homogeneous. Write it in your short. Any monosaccharide and any disaccharide completely dissolved in water forming a homogeneous solution. I'll erase this additional thing point here. You copy down this now. Right everyone? Any monosaccharide? Grade 10 biology. Any disaccharide? All the monosaccharides and disaccharides completely soluble in water result in homogeneous mixtures. Right here. All the right everyone, all the monosaccharides. A short method. What are monosaccharides? Glucose, galactose and fructose. Fructose. And all the monosaccharides and all the disaccharides. What are the three disaccharides? Sucrose, maltose, lactose are completely soluble in water. Completely soluble in water. Forming what mixtures? Forming homogeneous mixtures or homogeneous solution. Very important. All the monosaccharide, add this, because this is not given in your textbook. You have to add this to a short note. All the monosaccharides, and all the disaccharides with water form what mixtures? Homogeneous mixture. So homogeneous solution. Glucose solution, sucrose solution, maltose solution, lactose solution, galactose solution, they are all homogeneous. Copper sulfate solution, it's an ionic compound. Not only that, sodium chloride completely soluble in water, it produces homogeneous mixtures. Copper sulfate solution, salt solution, sodium chloride solution, that also homogeneous. If you take Condis solution, what is Condis? Potassium permanganate, Condis, that also homogeneous. If you only write within bracket KMnO4, it is an ionic compound completely dissolved in water. Copper sulfate also ionic compound. Most of the ionic compounds are completely soluble in water and produce homogeneous mixtures with water. So it's not hard because you need this some prior knowledge also to understand this. Because you had done ionic compounds, you had done covalent compounds, you had done monosaccharide, you have learned before. Disaccharide also you have learned. So then that previous knowledge also helps to understand this. Anyone still copying down? Shall I raise? Anyone still copying down? Raise the hand. Okay, I'll erase now. You had enough time to copy down. Next one, heterogeneous mixtures. Heterogeneous mixtures means what? Composition changes from place to place. Appearance, color, density changes from place to place. Unevenly distributed. Components are unevenly distributed. That's what it means. So we'll complete the blank. Mixtures in which components can be distinguished. Okay, I'll ask a simple question. Who can tell me the answer for this? Milo packet or milk packet, vanilla flavored milk packet or Milo packet, homogeneous or heterogeneous? Who can tell me whether Milo packet and this one homogeneous or heterogeneous? Common sense. It's not given in your textbook, but you can ask this applications in next time. I'll ask the answer from Netu, yes. But it's homogeneous or heterogeneous?
Heterogeneous.
Homogeneous.
Milo packet homogeneous or heterogeneous? Sujivani, Vinanga,
Heterogeneous.
Siddhani.
Heterogeneous.
Heterogeneous.
Heterogeneous. Heterogeneous.
Yeah, correct. Very good. It's heterogeneous. Milo packet or milk powder, not milk powder, vanilla, the milk flavored milk packet, vanilla milk packet or Milo packet, it's heterogeneous. How do you know? Have you all seen they put on the label shake well before drinking? Shake well before drinking. Now, okay, I'll give one more example. I'll ask this question also. I'll show the this one also, the small image also. I'll try to get from the internet. Tipexo correction fluid. That's why they are asking shake well before drinking. What is this Milo packet and milk powder packet? Because until you shake this, it's heterogeneous. Particles settle at the bottom. Particles settle at the bottom. When you shake, it's going to be homogeneous. Again, if you are leaving that milk packet for a while, it's going to be heterogeneous, right? Okay, I'll ask one more question. Who can tell me this correction fluid or Tipex? Correction fluid, homogeneous or heterogeneous? Correction fluid, homogeneous or heterogeneous? I don't know whether you have seen the label. I don't know whether it's readable here. The label, if you look at, you have a Tipex in your hand, you can check whether it's, I don't know whether it's clear. The letters are very small printed on. You will need sometimes a hand lens or something. It's I don't know whether it's no. They have put lot of letter. It's like on the label so many things, but it's not clear here. Definitely they'll put like, you know, it's harmful. If you inhale, it's harmful the content. Huh? Plus, it contain chemicals. It contain chemicals. And when you have to shake this before you apply, right? Why shaking well before apply? Hmm? It's heterogeneous. It's heterogeneous. And I think if you have, you can read it because it's not clear here. This table. Not only that, if you take, I'll ask medical syrup, homogeneous or heterogeneous? Medical syrup. Who can tell me? Medical syrup, most of the medical syrup, cough syrup. If you read the label of this, you will never use Tipex, right? If you, yeah, I'll ask the answer from Hera, Siddhani. Medical syrup, homogeneous or heterogeneous? Mela?
Heterogeneous.
Heterogeneous.
Yeah, it's heterogeneous. Very good. Yeah. Yeah, it's heterogeneous. Good. I think some of you can see here that cautious flammable. Heterogeneous. That's why shake well before. Otherwise, you are drinking only the solvent. Otherwise, you are drinking the solvent, not the medicine. Not the medicine. Right? Therefore, it's very important to understand that. Okay, so you now like that. If you are given from your day-to-day life any example like that, you should know whether it's homogeneous or heterogeneous. Milo pellet heterogeneous. Medical syrup heterogeneous. Shake well by before. I'll ask one more example. If you take this, people are drinking alcohol, beverages, beer, wine, and they mix that with soda and various stuff. Is that homogeneous or heterogeneous? After mixing Araco brandy or something with soda or water, is that homogeneous mixture or heterogeneous mixture? Who can tell me? Homogeneous or heterogeneous? Netu, Sumela?
Heterogeneous.
Heterogeneous. Alcohol with water, heterogeneous. Alcohol with soda, heterogeneous. Or homogeneous. Supulsara, Randir, Nisula, Siddhartha?
Homogeneous.
Yeah, it's homogeneous, not regular. Have you seen the in a party while shake while drinking? A glass, a wine cup, wine glass, or brandy or whatever. They mix with soda, little bit of soda or water, and they drink. Do they give? Are they drinking this while shaking? Right? No, right? No need to shake while before drinking. No, no need to shake while drinking. But if you have maybe a glass of fruit juice, yes, particles settle with time. Therefore, you need the straw. Something you mix this well from time to time. The straw, the fruit juice, or fruit salad, or curry, heterogeneous. If you take even mortar, badam, concrete, so it's heterogeneous. You can see the particles through your naked eye. The fruit, the pieces of the fruits and all you can see because it's heterogeneous. Plenty homogeneous or heterogeneous. Just plain without mixing with milk, without adding milk. A plenty, no, like just plenty. Homogeneous or heterogeneous? Who can tell me? Pulsara, Subela.
Heterogeneous.
Homogeneous.
Plenty also shake well before drinking, or shake while you are drinking plenty, like the Milo packet. No need to shake the plenty. Common sense. Plenty is homogeneous. But if you add in milk, milk tea heterogeneous. Milk tea with time particles settle to the bottom. Again, you have to mix well with the spoon. Now, no point of doing this lesson if when you are given something like that in the oral paper, that's how you ask the questions. That's how you get the questions in the oral paper. They will give practical applications. No point of memorizing the definition of homogeneous and heterogeneous if you can't categorize when something is given around us whether it's homo or hetero. So remember the milk tea heterogeneous, plain tea, coffee heterogeneous, particles settle with time, coffee. Okay. If you take this after making a curry in the kitchen, the pan, we call it kiri hodda. It's heterogeneous because every time when you serve it, you have to mix well this curry. Otherwise, particles settle at the bottom and the water-like substance floating at the top. Even the fruit juice like that. Okay. Mixtures in which components can be distinguished from one another and physical properties not identical everywhere. Not identical. Or you can write separately. Components are unevenly distributed. If you want to write here within bracket, components are unevenly distributed. Components are unevenly distributed, not evenly, unevenly. Components are unevenly distributed. Unevenly distributed. Or not uniform. No uniform composition. If you want, you can write down some properties of heterogeneous mixtures, then it's easy. Because sometimes in the oral paper you can get MCQs. MCQs, not the definition, they will give which of the following is incorrect about mixtures. They can give what? Different statements about this. Then you should know what to write. Write separately characteristics or the properties of heterogeneous mixtures. All right, number 1. Properties of, write separately in your writing book, everyone. Properties of heterogeneous mixtures. Properties of heterogeneous mixtures. Number 1. Properties of heterogeneous mixtures. Number 1, you can write. Composition changes from place to place. Composition changes from place to place in the mixture. Appearance or the physical properties changes. Composition not same throughout, in other words. Physical properties changes. From place to place. That means color not same throughout. Or physical properties not same throughout. Right here, not uniform throughout. Not uniform. Components of the mixture visible. Of the mixture visible to the naked eye. Muddy water, you can see the mud particle, sand particle. They will never define heterogeneous mixtures. What is known as a heterogeneous mixtures? You don't get to write a paragraph about this, but they can ask simple questions like what is known as, which of the following is incorrect about heterogeneous mixture? Which of the following is correct about heterogeneous mixtures? Like that they can ask questions, MCQs. Or they can give structured essay, not essay type questions. This third lesson, the hardest part you get at the end. Separation technique like distillation, solvent extraction, chromatography, solubility and solution, preparation of solution practical. The first part of this lesson, you get mostly MCQs and structured set of questions about homogeneous and heterogeneous mixtures. So I'll erase this now. You can copy down some examples for this. I have not given some examples. Can you write some examples also for this? Wait. Did you all finish copying down? Anyone else writing? Raise the hand. Done, right? Okay. I'll erase this part. You are still writing? Okay. When you're done, please lower your hand. Quickly copy down. Can you all please write some examples here in some space? Some examples for this heterogeneous mixtures. Few examples you can write here. Just below that, I have not given examples. You can write it. Few examples write for the heterogeneous mixtures. You can write here concrete mixture. You can see the particles. Medical syrups. Medical syrup. Then wheat flour in water. Wheat flour in water. It's heterogeneous. It doesn't dissolve well. You can write milk tea, muddy water, heterogeneous. Write few examples. Clay dissolved in water, heterogeneous. Maybe fruit salad, heterogeneous. Fruit salad also heterogeneous. Then if you take this laundry blue with water, for washing whitening clothes they use laundry blue in water also heterogeneous. Added to clothes. Okay, that's enough. You can write many examples, right? Then I have given here small practical that you can do even in school. You have done double displacement reaction in school. So if you take this, if you mix barium chloride, what the chemical formula? BaCl2. You mix this sodium sulfate, then you get a product barium sulfate BaSO4. It's a precipitate, BaSO4. It is a precipitate. And sodium chloride. What are the two products you get here? Barium sulfate and sodium chloride. NaCl solution. NaCl solution dissolves and floating at the top. Barium sulfate is a precipitate. I put solid here. So before you mix, both are homogeneous. But after mixing, it becomes heterogeneous. If you want to write here the barium chloride aqueous solution, homogeneous. I just put homo. Sodium sulfate aqueous solution also homogeneous. But after mixing, it becomes heterogeneous. Heterogeneous. Because particle, the barium chloride, it from a cloudy solution, its particles settle at the bottom. And the rest is floating in the solvent. So what is the word equation? What are the two products when you mix barium chloride and sodium sulfate? You get barium combined with sulfate, you get barium sulfate. So chemically you can mix chemicals and check whether there is going to form homogeneous mixture or heterogeneous mixture. Barium sulfate plus sodium chloride plus sodium chloride. Complete the equation here. Plus sodium chloride. So we'll write the balanced chemical equation. Barium chloride BaCl2, it's a homogeneous solution, aqueous solution, plus sodium sulfate Na2SO4, that is also homogeneous solution, aqueous. And when you combine these two, you get barium sulfate BaSO4, that is a precipitate, solid, S, plus sodium chloride NaCl, that is aqueous. For balancing, you have to put 2 NaCl, but there's 2 chlorine, 2 sodium here. Look at left side, 2 chlorine and 2 sodium. Therefore, you have to make it 2 NaCl for balancing. Barium 1 1, sulfate 1 1. So it's already balanced. So actually, This is a double displacement reaction. It's a precipitation reaction as well as double displacement reaction. Barium combined with whom? Sulfate and form barium sulfate. Sodium combined with chlorine and become NaCl. Can you please write here, this is a double displacement reaction. This is a double displacement reaction. According to grade 10 chemistry, a double displacement reaction. A double displacement reaction. This is a double displacement reaction. You mix two homogeneous solutions. The resulting solution is heterogeneous. If you want to write here, before mixing homogeneous, after mixing it becomes heterogeneous. Before mixing homogeneous. If you want to write that separately with a pencil, barium chloride solution homogeneous. Before mixing homogeneous. But after mixing heterogeneous. After mixing it becomes heterogeneous. After mixing heterogeneous. That's very important. Done. Shall I erase this? Anyone still copying down? So basically, if I can summarize, I told you matter can be divided as pure substance and mixtures. Pure substance can be elements and compounds. Mixtures can be homogeneous or heterogeneous. Pure substance has a chemical formula. Mixture, no definite chemical formula. If you are drinking plain tea from 3 different houses, it can be 3 different compositions. Same plain, it's plain tea, all 3 plain tea, but all 3 milk tea. If you go to 3 different hotels and have a iced coffee, you can see the taste sometimes changes, appearance changes, because it's heterogeneous. You can't give a chemical formula, composition changes. The same plain tea, but it changes with the person who made it. Some people they put more sugar, some they put less. So that means different composition. I'll erase the screen. Page number 2. This one you have to do it alone without my help. I'll do 1 or 2 for you, and then the rest you have to continue with the pencil. If you are sure, if you are not sure, you can complete with the pencil, and then I'll correct it. Right. First one I'll do you. So first I have given solute and solvent. A solution consists of a solute and a solvent. Now if you take salt solution, look at here. First look at the example. Example given salt solution. To make this salt solution, what is added? Salt dissolved in water. So solvent is water. Salt is solid. Solvent is liquid. Therefore it is a solid liquid mixture. Solid dash liquid. It is a solid liquid mixture. Sodium chloride common salt. It is solid, water is liquid. And is homogeneous. Now I'll give 5 minutes. Can you finish the rest? Complete. I'll ask one by one. You can't just stay silent. Whatever you had done, you have to tell me. Complete the rest now. the same pattern you have to continue the rest. Please raise the hand those who have got a hard copy of this printout. How many of you are writing on the hard copy now? Please raise the hand those who have got the printout of this tute. There are more than 50 students. 20 only. 21, 22. Right. Now the others, you make, if you have a CR book, you no need to worry. You can just like, not long paragraph, just words, so you can quickly write it. Anyway, it's up to you to decide. If you want, you can copy down everything in your CR book, or if you are familiar with the printout, then you can get the printout and have, but you have to file it. You should not misplace them. The theory tute will be the note at the end. You have to study from this tute. Because I am not given a separate additional note. So this theory this one will be this theory tute will be your note at the end. Because it's easy to refer. I don't give the long paragraph here. Just a separate format. Used to revise this easily, because when the oral exam is close, you can't revise 35 lessons within 1 week. Then you need this kind of note. Okay, hurry up, quickly complete all the possible ones. If you find it difficult, if you can't decide, then you can leave it. Okay, who can tell me number 2? Okay, first one I have done for you. Second one, who can tell me the answer? Any volunteers? I'll ask the answer from Nilakshi.
Solid, liquid, homogeneous.
Very good. Solid, liquid, homogeneous. Correct. Write here condensed, but can you write the color of the solution also within bracket? It's same appearance so throughout. This condensed solution is purple. Purple color solution. Potassium permanganate, that is an ionic compound. KMnO4. Actually, color comes because of manganese, not because of potassium. Group 1 metals cannot make colored compounds. Right, if you want. Group 1 and group 2 metals, they don't form colored compounds. This color comes from manganese here, purple color, condiso potassium permanganate. It dissolves well. It's an ionic compound. Who can tell me the third one, the answer? Any volunteers? Rohini? Third one, yes. Netu?
Solid, liquid, heterogeneous.
And it is solid liquid mixture, and it is heterogeneous.
Okay, Rohin, right. Right, correct. Solid liquid, it's heterogeneous, correct. Next one. Number 4. Any volunteers? Fourth one, who can tell me the answer? Nivedita?
Solid, liquid, homogeneous.
Right, solid liquid, and whether it's homo hetero?
Homogeneous.
Solid, liquid, homogeneous.
Yeah, correct, very good. Solid liquid is homogeneous. Very good. Next one, number 4. Number 5. Washing powder and water. This one. So the first 4 we did, right? 1, 2, 3, 4, 5. Yeah, now we are doing number 5. Washing powder with water. Any volunteers? Sumela?
solid liquid homogeneous mixture.
Correct, Sumela. It's solid liquid. Washing powder actually. It depends. So yeah, if some washing powder completely dissolved, you can take homogeneous. Yeah, correct. It's washing powder solution, no? Some we call it detergents. Liquid detergents also available in the market. Laundry brew. Number 6. Laundry brew. Sometimes we call it nil, like in some white frocks, white uniform. They put this laundry brew, they mix it water and soak the material or the frock or the shirt or whatever the garments or whatever your uniform, and then they dry it and it's giving extra whitening. I don't know how many of you have seen this laundry blue. Yes, what is this? It's homogeneous or heterogeneous? I'll ask the answer from Sedani, Nivedita, Minanga.
Liquid heterogeneous.
Liquid homogeneous.
Yeah, actually it's like this. Laundry blue, it's available in the powdered form also. It depends on the situation that you use. So if you write laundry blue, it's available in the solid form. And then it's solid liquid homogeneous mixture or solid liquid heterogeneous mixture, laundry blue. They have given this in your textbook page number 33 bottom, right? It's heterogeneous. If you leave that for a while and soak, then what happened? Some areas of your white uniform dark blue. So that's why immediately after mixing you have to soak that. If you are leaving for a while, then it can settle like the party. So solid liquid, it's heterogeneous. So the previous one you can write washing powder solution. Alcohol in water. Yes, who can tell me the number 7, any volunteers? Amandi? Diana?
Liquid homogeneous.
Very good. Liquid homogeneous. Very good. You don't shake while drinking. It's a homogeneous solution, no need to shake while drinking. Homogeneous. Number 8. Coconut oil in water. What is the solute? What is the solvent? Yes, any volunteers? I'll ask the answer from Isula.
Solute is coconut water, solvent is water, it is liquid heterogeneous.
Yeah, coconut oil, solvent water. I would just LL because it takes less time. So I put liquid dash LL. It's heterogeneous because coconut oil doesn't dissolve well in water. Number 9. Zinc and copper. Any volunteers? What is the type of mixture? If you mix zinc and copper and if you melt it and solidify again, you melt two metals into liquid form and then you mix it and solidify again. Who can tell me number 9? Dion?
Solid homogeneous, and it forms brass.
Very good, correct, very good, excellent. Yeah, Dion, solid, and it is homogeneous, and it is brass. Example, brass. Actually, brass has higher percentage copper and lower percentage zinc. Brass having higher percentage copper and lower percentage zinc, about 65% copper. No need to memorize. About 65% copper and around 35% zinc. Then number 10, any volunteers? 10th one, What is SN? Tin. SN is tin. Who can tell me? I'll ask from Herat.
Solid homogeneous.
Very good. Solid homogeneous. It's bronze. Number 11, tin and lead. It's solder. Yes, Sujivani.
Solid homogeneous.
Very good. Solid homogeneous. Solder is solid homogeneous. Basically, now the last one, number two, one before last one, 12th one, copper plus gold. Yes, who can tell me copper plus gold? I'll ask from Omandi.
Solid homogeneous.
Solid homogeneous. Very good. So we call it 22 karat gold. That's very important. It is 22 karat gold. It is not pure gold. Now when the carat value goes up, the price increase, because higher the carat value, higher the gold percentage. 18 karat gold less expensive than 22 karat gold, because 18 karat gold more copper. Can't they make jewelries only with gold? Then it is not strong enough, right? Why do they mix copper? To increase the strength. Last one, number 13. Who can tell me the answer? I'll ask the answer from. What about the other students? Same race, students raising the hand most of the time. Nisula, tell me the last one, the answer.
Solid heterogeneous.
Correct, Nisula. Solid heterogeneous. Condensed and iron powder do not mix well. So it's heterogeneous. You can see the iron particles among the condensed particles. If you dissolve, condensed will dissolve, but not the iron powder. Right. So like that, when you are given a mixture, you should be able to classify this based on the physical state and based on the composition. The last three I have done for you. One of the best example, this soda bottle. This one you can highlight. Open soda bottle, heterogeneous, important, because CO2 gas is coming out. When you open this soda bottle, it becomes heterogeneous. CO2 bubbles coming out, right? Foam will come out. But if you take the fresh soda bottle, before you open it, we call it homogeneous. So what is the gas present in soda water? It's carbon dioxide. Actually, when you pass carbon dioxide gas into water, it forms this reaction. If you only write here, when you pass CO2 gas into water, CO2 plus H2O, you get H2CO3. You get H2CO3. We call it carbonic acid. What is called carbonic acid? Aqueous. So this is the reaction. When you pass, it's a chemical combination reaction. CO2 plus water, you get H2CO3. But it's a reversible reaction. When you open the soda bottle, this will again break down back to this. Reversible reaction. That's why soda is not good for the people having gastritis, because it's acidic. Carbon dioxide is an acidic gas. This carbonic is a weak acid. This is a weak acid. You can copy down this addition information also here. AQ. CO2 gas, not here. This is gas G. pH is below 7. Acidic. This is present in, if you take more than 70% of the earth covered by water, large quantity of CO2 held in water actually. Otherwise, due to the thermal expansion of seawater, global warming become worst. Dissolved CO2 will go to the atmosphere. Atmospheric CO2 increase. It can cause the greenhouse effect more severe. I mean, an increase, result in global warming and temperature of the earth will increase. Last one, gases dissolved in water, forming homogeneous mixture. So yeah, now example, when you drink water, dissolved gases available. When you drink a glass of water, it contains dissolved gases. So gas is not visible to your naked eye, it's homogeneous. Right. Then shall I erase this? Did you finish copying down? So that's about this homogeneous and heterogeneous. That's the end of homogeneous and heterogeneous thing. So it's not hard. You have to be very, when you are given any example, you should know how to classify this. Whether it's homogeneous or heterogeneous, whether it's solid or liquid solid or gas. And the other most important thing, when you write this solid gas, liquid solid gas, first what should come? The solute. Solute should come first, then the solvent. You can't make this liquid gas. Now soda bottle, don't make it liquid gas, so it's gas liquid. Solute and solvent should come next. That was a bit important. Soda bottle, the gas will be the solute. Carbon dioxide gas, liquid will be the water will be the liquid or the solvent. Solute, I'll write here solvent. So this order you should not change, okay? What should come first? Which one, the physical state of whom should come first? Solute, not the solvent. Okay, I'll erase this now. Number 6. Solvents can be classified into two types according to the polarity. This is very important. Polarity. This word highlight, polarity word, very important. What is the meaning of polarity? Polar. What is the opposite of polar? Non-polar. Based on polarity, now the rest we are going to discuss about the solvents. Solvent. We are going to discuss a bit in detail about the solvents. Some solvents are polar, some solvents are non-polar. Therefore, solvents we can divide into two groups based on their polarity. What? Polar solvents and non-polar solvents. Polar solvents and non-polar solvents. Make it as simple. Non-polar solvents. Polar and non-polar solvents. So what are polar solvents? Polar means those solvents, actually they are made of molecules, and those molecules contain some polar groups like what? OH, NH, HF. So these are called polar groups. So I'll write here polar groups. One of the best example. Now if you take water molecule H2O, look at the screen everyone. Water contain what group? OH group. So if you draw water molecule, it's a polar solvent. H2O, it has OH group. It's a polar group. Ethanol also contain OH group. Ethanol, C2H5OH, this OH act as a polar group. Why oxygen is, now if you take a look at this here, I'll draw that also. C2H5OH, if you draw ethanol, C2H5OH. So actually what happens here, ethanol, ethyl alcohol, OH. So this oxygen becomes slightly negative. Hydrogen becomes slightly positive. So we call it delta plus here. This is called delta minus. Here also H is delta plus, O is delta minus. So that is a polar group. This is a polar group. OH group is a polar group. Here OH will be the polar group. Why? It has small positive and negative charges. Polar groups contain what? Small positive and negative charges. Small positive and negative charges on the atoms. How come positive and negative? You have done no grade 10, nothing new. Grade 10 electronegativity. Grade 10 electronegativity, oxygen is more electronegative. What is the electronegativity of oxygen? 3.5. What is the electronegativity of hydrogen? 2.1. Who is more electronegative? Oxygen. Therefore, electrons are attracted more towards whom? Oxygen atom. The most electronegative oxygen attracts the electrons. One who attracts electron becomes slightly negative. This is called delta. This, it looks like the letter S here. Delta. Delta. You can't write just plus and minus. If it, then it's become ionic compound. If you put without delta, if you put plus and minus, it's like sodium chloride. Then it's become fully ionic. Then it's extremely polar means ionic. So they can't nothing delta. So it's fully separated. Sodium has lost the electron completely to chlorine. But here not completely. Partially electrons are attracted towards the oxygen. Actually this is a polar covalent bond. What is this bond called? Polar covalent bond. It's not 100% ionic. It's polar covalent bond. Here this is a covalent molecule. Water has two covalent bonds, but it's a polar covalent bond. But if you take identical atoms like homoatomic one like hydrogen, HH, then what? Electrons are equally shared, symmetrical. Electrons are not attracted either side much. Electronegativity equal. If electronegativity equal, electrons are equally shared. That's called equal sharing. Then is non-polar. Then none of the atoms become plus or minus. So therefore H2 is non-polar. Non-polar covalent bond. H2 has non-polar covalent bond. You can see now the covalent bonds you can put into two types. What? Polar covalent and non-polar covalent. Now I'll give one example. HCl. HCl is what? Not identical atoms. Heteroatomic. Who is more electronegative? Chlorine. Chlorine 3.0. No need to remember the values, but you should know which element has higher electronegativity. Hydrogen 2.1. Look at the electronegativity table, grade 10 textbook, chapter 3. Now, chlorine becomes slightly negative, delta minus. Hydrogen becomes slightly positive, delta plus. Therefore, it's become what? Covalent bond, polar covalent bond. HCl is polar covalent bond. Polar covalent bond. You can copy down this additional information in your writing book. Sumela, any question?
Sir, does the methane gas is a polar component or non-polar component?
Very good question, Sumela. Okay, I'll explain that. Very good question. Methane, look at the screen. If you take methane, CH4, this is very interesting. You should better, definitely everyone should better copy down this in your right book. CH4 methane. Sumela, this one, each bond is polar. Why? This is no doubt. Now this is now no need to get confused. If the bond is formed between different atoms, that bond is polar. Right, everyone? Put a stand right. If covalent bond is formed between different atoms, if covalent bond is formed between different atoms, we call it heteroatomic. Different atoms means heteroatomic. If the bond is formed between different atoms, it is if the bond is formed between, if covalent bond is formed between different atoms, it is a polar covalent bond. I will highlight this word again. Again, I am telling different atoms. It's a polar covalent bond. If the covalent bond is between different atoms, it is a polar covalent bond. Now, C and H, are they same atom? No, different atom. Who is more electronegative? CH4, there are 4 covalent bond. Carbon, what is the electronegativity? 2.5. Hydrogen, 2.1. So, their electronegativity different, not the same. Therefore, carbon becomes slightly minus and hydrogen becomes slightly plus. But this is the most important thing. Many students get confused, but this is a non-polar molecule. Molecule is non-polar. Non-polar molecule with polar covalent bond. Even A-level chemistry students also, they mix up this. Non-polar molecule with polar covalent bond. Each bond is polar. But the overall molecule is non-polar. Actually, you have done here resultant forces, can you remember? So actually this get cancelled. It's a symmetrical molecule. Each bond is polar, but the overall molecule is non-polar. That means plus and minus charges do not retain permanently on the individual atom. It get balanced. Imagine you are pulling 4 different directions like this. What happened? The resultant force 0. Something like that. Even carbon dioxide, the same scenario. Carbon dioxide, CO2, the bond is polar, but CO2 molecule is non-polar. Look at here CO2. Please copy down these things. Even the teachers also, they don't explain this properly. You will understand this when you are doing one day. They don't tell this much. CO2, non-polar molecule with polar bond. Non-polar molecule with polar bond. How to decide whether bond is polar or non-polar? Check whether the atoms around the bond same or different. That's it. If the atoms are different around the bond, it's a polar bond. If the atoms are same, like H2, O2, N2, Cl2, Br2, I2, it's non-polar. N2 non-polar. Molecule also non-polar, bond also non-polar. So write CO2, non-polar molecule with polar bond. Good that you asked the question, Sumera, because when you ask questions, you get more knowledge, definitely. Because I know some of you are planning to do A-level bioscience, some of you are planning to do A-level. Now remember, no future without science-related subject in the future. You can see you are in the. This is what technological revolution. You are in the era of technological revolution. IT bus also has gone to a certain extent now. Technological revolution. You have passed many revolutions. Industrial revolution. Now you are in the technological revolution. If you don't update this knowledge, IT, math science going to rule the world in the future. Nanotechnology, robotics, mechatronics, AI. Therefore, if you don't touch those areas for your higher studies, you will be in trouble. You become jobless. Now also I can survive because of this technology, right? Otherwise I can just curfew, no transport, no electricity. Therefore I can stay at home without doing anything. Depend on the government salary only. Remember that. If I don't have a little bit of idea knowledge, then no point of my science knowledge now. If I know only science now, therefore remember you should know something about everything in the future. You can't rely on only this. You should be expert. You should get specialized in one area or one field, but you should be able to, especially technology. Technology means not only IT, not only computer science. Right? Now, now when with pandemic situation, who started this online thing first? The IT teachers. After that, what happened? The singular teacher, and I'm not telling you all the teachers. Some are very good in IT and those technological stuff, but many teachers, those who are in the other subject, they were struggling to do this online. They are very good in teaching. They are very good at teaching, but the technological failure. Even in the university, there are 70 years old, maybe 50, 60 years about to retire the lecturers, professors. So their IT knowledge is very good. Remember now, not only the just our literacy. So IT literacy important, scientific literacy important as a country, technological literacy important. We are just talking about only literacy. Now the others also will affect to the, if now example, if I can, now people are struggling now dollars. Now you might not believe, if some countries, many foreign teachers now India, everywhere in the world, Indian people are working in the IT sector. Most of the US companies, IT companies in the USA, Indian people, they bring a lot of money to the India, the foreign currency. So if I can do, now I am teaching your local students, but if I can do international students, if I can teach, if I can stay in Sri Lanka and teach, I can bring more dollars to my country. We don't need to send our mothers to the for labor works to housemaid as housemaids to the other countries. So that's why we need people come with innovative ideas, innovative solutions. We don't need people in our country those who create problems. We need the people with smart solutions for the existing problems. So that's why I'm telling, like, if you know at least one subject very well, you can teach the other students, international community. You can stay in Sri Lanka and you can bring many dollars. Now we are sending large amount of money to this Zoom app. Even I'm spending a lot. You can see the dollar rate now. It's reaching to 400. So it's almost double now. With compared to the pandemic, like about 2 years back, it was around 180. Now it's reaching to nearly 400. So then you can imagine the situation, the amount of money we are sending out of the country. We need people who are not following the Facebook or the WhatsApp or the social media. We need the people, those who are creating these things. Facebook creators or Zoom like app creating, those who can create something. We are still depend on USA. So these people, they become, I think, the one of the richest people like in the world now. So this is what I'm telling. Right. Okay. Anyway, it's up to you to decide. So because you all are facing the next challenges in the future and the next generation, when you are doing your higher studies, you have to pay attention to these areas, these things. Okay. Back to this. The other most important, I told what? Copy down this also separately. If you take N2, O2, H2, N2, O2. What about these things? Bond also polar, molecule, bond also non-polar, molecule also non-polar. Look at here H2. H2 polar or non-polar covalent bond, non-polar covalent bond. Molecule also non-polar, bond also non-polar. This is the other opposite of this. Non-polar molecule with non-polar bond. Non-polar H2. Look at here. H2 is non-polar molecule with non-polar bond. With non-polar bond. Some molecules can contain both polar and non-polar bonds. Very rarely. Right? Very rarely. But most of the molecules contain either polar or only non-polar bond. But by looking at the bond, you can't decide whether the molecule is polar or non-polar. Again, I am telling you, by looking at only the bond, you can't tell whether it's polar or non-polar. You have to look at the overall molecule also. Basically, if a molecule has CH bonds, it's going to be a non-polar molecule. CH. If CH bonds are present, the bond is polar, but the molecule is going to be non-polar. But water, Water, the bond is polar, the molecule also non-polar. What matters actually, it's A-level chemistry, they will teach the rest. Actually, you can't have the complete knowledge here because you don't learn that part yet. In A-level chemistry, they will give the complete knowledge to decide this. Water, the shape of the molecule also matters for this. Sometimes you might argue, sir, all the bonds are non-polar. All the bonds are polar. How can the molecule become non-polar? You can argue. You can ask all four CH bonds here polar. Why did you tell the CH4 molecule is non-polar? So what matters here, the geometry or the symmetry or the arrangement of this molecule in the space also matters. Water molecule is angular. That's why it is polar. Carbon dioxide molecule is linear. Geometry or the shape of the molecule also matters. That is out of your oral chemistry syllabus. Therefore, I'm not going to explain that part here. Just remember, a non-polar molecule can have polar bonds. That's it. And how to decide whether it's a polar or non-polar bond? If the atoms are similar, non-polar covalent bond. If the atoms are different, polar covalent bond. That's it. That is what you have to write in your, with the red pen, write it. Where did I put that somewhere? If the bond is formed between different atoms, it's non-polar. Polar. Right. Can you write that separate? I didn't write here. Please write with the red pen. If the bond is formed between different atoms, that bond is polar. Between different atoms, polar bond. Between similar atoms, non-polar bond. That's it. Between similar atoms. Between identical atoms. Between identical atoms or similar atoms, non-polar bond. Between identical atoms, non-polar covalent bond. Non-polar covalent bond. Between, I look at the screen, I'm writing this part, this you have to copy down, this bit important. Between identical atoms or similar atoms, non-polar covalent bond, not molecular bond, non-polar covalent bond here, bond, BOND. And between different atoms or heteroatomic, that is polar covalent bond. You better copy down this with the red pen in your short notebook or writing book. Polar covalent bond. This is how you can easily decide whether a bond is polar or non-polar. That's it. Nothing else. This is how you can easily decide whether a bond is polar or non-polar. Similar atoms, non-polar covalent bond. Different atoms, polar covalent bond. Then the other one, that is the bond. Then the molecule is different story. Molecule can be with polar or with non-polar bonds. It can be non-polar molecule or polar molecule. But I gave some conditions here. If a molecule has OH group, water, ethanol, ethanoic acid, NH bond, HF bond, they are going to be polar molecule. Polar molecule. Any questions? Shall I erase this now? I gave a lot of information because many teachers find it difficult to explain this polar and non-polar thing. Because electronegativity also you need here. Sumela, any more doubts?
The ammonia molecule can be get as a polar component because it is not having a geometrical shape. No?
Very good. Yeah, ammonia, it has a trigonal pyramidal shape here. Okay, shall I erase this? Did you anyone still copy down this? Shall I erase this? I'll explain ammonia also. NH3, ammonia is a basic gas. It has 3 NH bonds. Okay, so it's like this. Ammonia, it's not pointed like, nice arrangement, like there's no symmetrical geometry. NH3 ammonia, it's a basic gas. It has 3 NH bonds. Ammonia, each bond is polar. Look at the screen since you asked that. Ammonia NH3, each bond is polar. So this is a polar covalent bond. And the molecule also polar. Polar covalent bond and polar molecule. NH3 is a polar molecule, polar covalent bond, and this is a polar molecule. Molecule also polar, bonds also polar. Why? Because it's not like CH4. It's like all four sides it's not getting cancelled here. The dipole moment or that attraction. Attractions won't get cancelled here. Actually, if you, this is not the real arrangement. If you only can go to the internet and write geometry of ammonia molecule, then you'll get this is actually it's look like this ammonia. So what happened now? All three bonds, so the electrons are attracted towards whom? Nitrogen atom, because nitrogen is more electronegative. Nitrogen become delta minus, and the permanent plus and minus charges retains on the atoms. That's why it won't get cancelled. Therefore, ammonia become a polar molecule. On the nitrogen atom, there's a negative charge, not 100% negative, like it's slightly negative. On hydrogen atom, slightly positive. Therefore, ammonia is a polar molecule. Ammonia dissolves in water. That's why you can't collect ammonia under water. Ammonia you can't collect underwater because it's soluble in water. It is soluble in water. Carbon dioxide, oxygen you can collect underwater, downward displacement of water. Carbon dioxide also dissolve to a certain extent, but not like ammonia. Ammonia, right? Basic gas, NH3. Not ammonium, huh? Ammonia. It's a basic gas. Ammonia is a basic gas. Please copy down this additional thing. Nothing, it's all this in the syllabus. I don't tell anything out of syllabus. It's a basic gas. And ammonium is NH4 plus. Ammonium is NH4 plus. Ammonium. When you pass ammonia gas into water, it becomes ammonium ion. I think well, I gave the answer for your question. Ammonia is, because of the shape of the molecule, it's going to be polar. But anyway, you don't need to memorize all the molecules in the world, whether it's polar or non-polar. Only the selected ones given in your syllabus only you have to remember. That's what I have given here. Look at the screen. Water. Look at here. Water is what? Polar, because of OH group. So these ones you remember. Because of OH group, ethanol polar. Because of OH group, water polar. Because of OH group, ammonia solution polar. Because of OH group, acetic acid or vinegar. So they all mix well. If you mix any of these, polar mix with polar, because like things attracts each other. They all polar solvents. Ethanol dissolve well in water. Vinegar dissolve well in water, because polar. Opposite charges attracts each other. So I have given a detailed explanation about how water molecule become polar. Look at the screen, everyone. Can you please write here near oxygen 3.5 electronegativity? Right, everyone, look at the screen. Near oxygen, right, electronegativity 3.5. Hydrogen 2.1. This hydrogen also 2.1. So this is a polar bond. This is a polar covalent bond. It's a polar covalent bond. Why? Electrons are attracted more. I told different atoms, oxygen and hydrogen, not the same atom. Therefore, definitely the bond is polar. Near oxygen, there's a small negative charge. Near hydrogen, there's a small positive charge. So complete the blank. Electronegativity of oxygen is greater than hydrogen. Greater than hydrogen. Therefore, the bonding electrons, be simple. Here, be simple. Therefore, bonding electrons are attracted more towards whom? More towards oxygen atom. Bonding electrons are attracted more towards oxygen atom than hydrogen atom. Complete the blank. It's very easy to understand. Very easy to understand. Common sense. Who is more electronegative? Oxygen. Therefore, who will attract electrons more toward that side? Oxygen. Then oxygen get what charge? One who attracts electron more gets slightly negative charge. Slightly negative charge. Slightly negative charge. And hydrogen gets slightly positive charge. Delta plus, delta minus. So I'll write here negative. Slightly negative charge, and hydrogen gets slightly positive charge. Positive charge. then the bond between H and O atoms become polar or non-polar? Bond becomes polar bond, polar covalent bond. If you write polar covalent, no, just write polar bond. Because anyway, only in covalent bonds we can talk about polar and non-polar. Otherwise, ionic, nothing to talk about. Polar is fully ionic because it's fully separated. Plus and minus charges. Charge separation completed. Since this is the main condition, small positive and negative charges on the atoms, it becomes what molecule? Water molecule on the molecule, in water molecule, it becomes what? Polar molecule. It becomes a polar molecule. Molecule also polar. Bond also polar. Polar bond and polar molecule. As what is made of polar molecule, it is considered as a polar solvent. It is a polar solvent. So basically this is what you have to remember. Water, bond polar, molecule polar, solvent also polar, right? Polar bond, water has polar bonds, polar molecule, as well as polar solvent, right? Everything. Water, bond also polar, molecule also polar, and it is a polar solvent. Polar bond, polar molecule, and polar solvent. Polar solvent. Why water is given here? Because water is one of the most important solvent in the world. Your blood main component water. Your urine main component water. Your sweat main component water. Your tears main component of water. Many body fluids. Your body fluids the main component water. Even if you take the earth, more than 70% highest percentage covered by water. Even if you take the plant body, highest percentage by mass, water. 2/3 of the any living body also water. So what is everywhere? What is available in all three physical states? What is available in the atmosphere? What is available in the soil? What is available in your living body? Without water, no life. That's why there's a separate topic, water, in grade 10 first chapter. Specific characteristics of water, coolant property, solvent property, specific heat capacity, adhesive cohesive forces and all. You learn all this. And many solutes dissolve in water because water is a polar. If water was non-polar, we are in a big trouble. Many things will not dissolve. We will not be able to transport many things in our blood. Actually, many things dissolved in blood because of water. Hormones, vitamins, minerals, nutrients, gases, excreted products, your blood content, all this, they all dissolve in blood because of water. You can't pass urine in the powdered form. You can't pass urine in the powdered form. To pass urine, you need enough water. You can't, plant cannot absorb fertilizers in the powdered form. There must be water. If fertilizers do not get dissolved in water, then how can plant absorb fertilizers? Therefore, water is the medium to absorb minerals to the plant, nutrients to the plant, even in our body. That's why after eating, you drink water to facilitate the digestion as well as for the absorption. Right. So I gave a detailed explanation, even though it took extra time. Now, finish copy down. It's almost 8 o'clock now. I'll stop. And this also you can copy down. This one I'll explain next day in case. Between polar molecules, the attractions. I will complete that one. Then it's finished. Only this one. This one, right? Between water molecules, we call it intermolecular bonds. You had done this in grade 10 chemistry also. Intermolecular bonds. Please write here intermolecular bonds. Only 2 minutes. After that, I'll stop. Intermolecular bonds or intermolecular forces between molecules. Between molecules, intermolecular bonds. Or we call it sometimes intermolecular. So this is a polar covalent bond. Within water molecule, polar covalent bond. Between molecules, intermolecular bond, or we call it intermolecular forces. These intermolecular forces because of the polarity. You can see the oppositely charged ends attracted to each other. Look at the screen here. This end is positive, this end is negative. So they are oppositely charged. One water molecule positive end, they are attracted to the other water molecule negative end. So this is called intermolecular force or intermolecular attractions. Intermolecular forces, some books say intermolecular attractions. Sometimes they tell all three accepted: intermolecular bond, intermolecular forces, or intermolecular attractions. That's why the water is held together as a liquid. Otherwise, water also you will have to breathe. Why water flows? Why water is a liquid? Because of intermolecular forces. They are attracted to each other. They are held together because of these intermolecular forces. Intercity, between cities. Intermolecular, between molecule. So attractions between oppositely charged ends. So this attraction occurs between the oppositely charged. One water molecule positive end, the other water molecule negative end of two water molecule is known as intermolecular bond. Complete the blank. Intermolecular bond. In A-level chemistry, we call it hydrogen bonding. In A-level chemistry, we call this hydrogen bonding. If you want to write that also within bracket additional information, if you are planning to A-level bioscience or max, this helps to keep water molecules together as a liquid. So therefore, water is a polar solvent. Right. Okay. So now it's almost 8:10. I'll stop for today, and next day I'll explain non-polar solvents. So polar, I gave a polar bond, polar molecule. I gave a detailed description, explanation, and you can watch the recording also if you want. Again, you can send a request if you miss anything. Right. Okay. Then stop for today. Tomorrow morning you have the paper class 5:30. Right. Have a good day and God bless you. Take care.